The electron configuration is a great shortcut to help us understand where each electron is without having to draw a bunch of arrows. Basically what we're doing is giving the electrons an address using the SPDF notation. So for hydrogen, it's going to be 1 energy level 1, S is the shape, we have only one electron there, so we use the exponent to tell how many electrons there are in that orbital. So for hydrogen, our configuration is 1s1. For helium, the configuration is first row, so 1, fills in the S level. So helium fills in the S. How many electrons go in? 2 electrons total. Now let's go down to the next row. Lithium is in the second ring, so before we can get to the second, we fill in the first row completely, 1s2, and then the second level, we're in the S orbital, so we put the S there. How many electrons go in there? Since it's the first one in its row, it's 1 electron in the S. And then beryllium, of course, would be 1 more electron than that, 1s2, 2s2. Well, now the S shell is full. So when we do the boron configuration, we're going to have to start filling in this new block over here. Remember, this is called the P block. So once we start filling in electrons into P orbitals, then we use that notation to tell where they are. So boron does 1s2 because we put an electron here and then here. Then we fill in the S in the second row, 2s2. Then to get to boron, we have to fill in a 2p with 1 electron, and that's it. That's our 5. So your exponents, 2 plus 2 plus 1, should add up to 5. If they don't add up to your atomic number, then you're not doing it right. Now let's do fluorine. All right, fluorine is a little farther from boron. So first fill in your first energy level, 1s2. Completely full, right? Because to get to fluorine, we're going to have to go all the way through here, from left to right, and from top to bottom until we land on fluorine. So we filled in the 1s completely. Now fill in your 2s, and we got to keep going, so fill that all the way in. What comes after the S? Then comes the P. So we're in row 2. In the P block, how many spaces? 1, 2, 3, 4, 5. So 2p, 5 to fill in fluorine. That's how we do electron configuration. Of course, it gets harder when we get more electrons to locate, but we're still going to go top to bottom, left to right. So now let's do sulfur. All right, so sulfur's down here, number 16. So we have 16 electrons to locate. We want our superscripts to add up to 16. First, we're going to start with the top row. These fill in 2 electrons in the 1s level. So we put 1s2. The next row, row 2, fills in 8 electrons total. How many go in the S block? Right, only 2, so 2s2. And then in the P block, how many can fill in over here? Count across. 1, 2, 3, 4, 5, 6 is the most we can hold in the second P block. So 2p can hold 6. Now we're down to the third row, right? We keep going top to bottom, left to right, until we land all the way over here on sulfur. Here's our S electrons. So we're in the third row, so we write a 3. The S block, so it's 3s. We can put at most 2 electrons there, so it's 3s2. What comes next? After the S, we gotta go across the gap. Now we're in the P block again, right? How many? 1, 2, 3, 4, and now we're on sulfur, so we have to stop. So in the 3p, we had 4 electrons, and I said we have to stop. So now let's add. Here's our exponents. 2 plus 2 plus 6 plus 2 and 4. So that makes a total of, let's see, 4 and 6 is 10, 12, 16 electrons and the atomic number for sulfur is indeed 16. So we've given every electron an address. We can also describe then how sulfur is going to react. What should we have? If this is going to be all the way full, then we should have a 3p6, and sulfur has a 3p4. So we know sulfur is going to react in such a way that it adds 2 electrons to its outer shell, and when it does, it's going to obtain a 2- charge because the electrons are negative. If we put 2 more in there, it's going to have a negative charge overall. So in the shortcut, which is really handy, basically we're going to use noble gas configuration to represent a complete energy level, and then that's going to be the shortcut. You see, noble gases have everything full as it can go in that particular row. So after a noble gas, we go down to the next row, right? Well then, if we show the noble gas as a shortcut, then it's going to help us. So let's just do calcium. Calcium is a handy one. Ah, that's the trouble. I've lost my pen. So we'll try using the pen from PowerPoint. Alright, calcium is element number 20. So I need to find a home for 20 electrons. We're going to go from left to right, top to bottom, just like we did before. So we're going to take our 1s and fill it up with 2 electrons. Then the 2s holds 2 electrons, and the 2p, remember, holds 6 electrons. Keep going, because we're not to calcium's row yet. Calcium is in row 4. So then next we have 3s with 2 electrons, and then 3p holds 6. Finally, we're down to row 4. Calcium is the second one over, and so we're going to put 4s2, and that's calcium. Now I said there's a shortcut, and here's where it is. If you look at the third row, then you'll see all of the electrons that we wrote in for calcium could be represented by just the configuration of argon. Everything in this third row fills in the same electrons as calcium up to argon, right? And so if I put argon here for a shortcut, then we would see, all right, everything that's here, argon has 2, so argon, that's going to hold the place of all of these. And then the rest that we have to write in is just what's in the fourth row, 4s2. The rule is you can only use a noble gas here, noble gas, in the brackets, because they're the only ones that have a complete energy level. So that's the only ones that you can put in the brackets for a shortcut. But it's really handy because we're going to get to some really, really big electrons. Alright, so check it out. Thanks to the shorthand configuration, we can do something as big as, say, fermium. 100 electrons. I know you're thinking 100 electrons. Really? Are we going to have to write 100 electrons? Yeah, we got to find out where they are. So for fermium, let's describe the location of 100 stinking electrons. Alright, we're in row 7. And so I'm going to go to the row higher than 7. Alright, which would be 6, yeah? 6 is higher than 7. Look at the end of row 6. Come all the way across to this guy, radon. So radon's going to have the same configuration as fermium up till the 6th level. So here's what I do. I'm going to write radon in brackets. Give me my pen back. So for writing fermium that has 100 electrons, I'm going to start with radon in the brackets. So now we just have to figure out what else does fermium have that radon doesn't. So after row 6 where we found the radon, what comes next? It would be row 7, right? We put 2 electrons into the s block in row 7. So I'm going to put 7s2 because we put 2 electrons in that s block in the 7th energy level. Then what? What comes next? After that one, we had, this was number 88, then comes number 89, actinium. So now we're down here in the F block. So if we had 7s, take away 2, that means now we're in the 5F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps to get to fermium. Well, you know what that means. Oh, where did my fermium go? Not there. That's all right, I can do this. Fermium with 100 had radon, then 7s2, and then what did we say? 5F had 12. And now, using our shorthand notation, I've represented 100 electrons because radon has 86 of them. Where does it go when I do that? Okay, I'm not used to this happening. Fermium needs 100 electrons. Radon has 86 of them. Then we have 7s2, so there's 2 more. And then 5f12, so there's 12 more. So that adds up to 100 total electrons. That's exactly what we were looking for to make fermium. Great. Okay folks, now that you've seen how to do the electron configurations, I've got a task for you to accomplish. You can answer this question by sending a text message to the number 37607, then in the text of your message, type in the code that you think matches the electron configuration that I've shown you at the top in the question. Or you can go online to http://polev.com and enter the code that you think is the correct answer. So give this a try and let's see how you do. Don't worry, I'm not going to know what your telephone number is when you send this to me, but I will know if you have responded. So let's take care of this and make sure you're doing it right. See you later.